is an article that just came out an hour ago by Newsweek. I didn't see anything about this in the mainstream media, but at any rate, NASA is warning that solar storm can, not definitely, but may hit Earth tomorrow, November 25th, as the sunspots increase tenfold. That's interesting. So the sun has become much more active, bursting with sunspots and sending plumes of hot plasma out into space. I think people should probably stay indoors tomorrow, depending, I guess, what country you live in and where you're from. In the last week alone, sunspot numbers have increased by 10 times, dotting the sun's surface with black pockmarks that's spewing out several coronal mass ejections every day. So one of these coronal mass ejections may be due to hit the Earth in the coming days, a NASA model has shown, with one possibly due to collide with our magnetic field and atmosphere late on November 25th. This will be confirmed after scientists fully analyze the trajectories of the storms. These coronal mass ejections are huge clouds of solar plasma that are spat out in the sun in regions of high magnetic activity, which can include sunspots. So they'll send out solar flares, which are bright bursts of electromagnetic energy. They're caused by the sun through its magnetic field being twisted and stressed through motions in the sun. A solar flare is the immense release of light triggered by the snapping and rearranging of the magnetic fields on the sun. They go hand in hand with the release of CME, but it will take a day or more for the particles to arrive while the light and radiation reaches us in just over 8 minutes. It says when they hit the Earth's magnetic field, it can trigger a geomagnetic storm. That occurs when the Earth's magnetic field is seriously disrupted by eruptions from the sun. So a plasma storm erupts from the sun, and that storm carries a magnetic field, which is oriented in an opposite direction to the Earth's magnetic field. So we have a perfect storm and a larger geomagnetic storm. They can vary in strength depending on the power of the CME that caused it, being measured on a scale between G1, which is a minor, to G5, which is extreme, according to NOAA. The most powerful of the storms are the least common. While there may be 1,700 G1 storms per 11-year solar cycle, we may only see 100 G4 storms and 4 G5 storms during the same period. When the CME hits and causes a geomagnetic storm, these particles are forced deeper into the atmosphere, causing them to react with more gases and causes the aurora to be brighter and visible further. So what consequence could it have? Well, other than pretty lights in the sky, geomagnetic storms can also lead to some impacts on infrastructure, like fluctuations and outages in the power grid and radio blackouts. So people, you might want to be prepared just in case. The affected infrastructure that is of most importance is large-scale power grids, without which modern society would not even be able to function. Other than that, pipelines, high frequency radio, radar, and satellites in orbit are significantly affected. They're known to carry geomagnetically induced currents, which accelerates their corrosion. Satellites can experience increased surface changing due to plasma. My internet went out today. That was kind of weird, but anyways, could be nothing. And this can affect the onboard electronics and operation of the satellite. Due to the amount of energy being dumped in the Earth's atmosphere during these big storms, the atmosphere actually swells and causes more satellite drag in low Earth orbit. The really minor geomagnetic storm in February 2022 that resulted in the loss of majority of Starlink deployment is a perfect example of how varying satellite drag can complicate space operations. Meanwhile, scientists are puzzled by ultra-powerful cosmic ray falling to the Earth. That was today. A powerful cosmic ray strikes the Earth from a mysterious, unknown origin. So, researchers involved in the telescope array experiment have identified an extraordinarily energetic cosmic ray named Amaterasu. It originated from outside our galaxy, and it boasts an energy level of approximately 240 electron volts. The analysis revealed that the direction from which this cosmic ray arrived does not align with any discernible source. The discovery of the Amaterasu particle is the questions remain unanswered of what type of particle is it. Anyways, what do you think about this particular happening, if you will? Hope you're having a good weekend. I think I'll stay indoors tomorrow. Bye.